Hi guys, I am Vignesh. Now we are going to create this product designs in a single revolve both features. Look at these three different kind of views. There is a front view, right side view as well as a top view. To create a complete 3D model, we are going to draw a single profiles. So select a front plane and create new sketch. Draw one vertical center line. Once we draw a profile, we give the overall dimensions also. So select this vertical line, then initiate the dimensions. It is 135 mm overall dimensions of the solid body. Once we create this primary profiles, now we are going to draw a sub profiles on this area. First draw one horizontal line. We are going to draw each profiles and constrain it one by one in a manner. Once we draw a line profile, what is the dimensions of it? The diameter of this profile is 12 mm. Now selecting this endpoint as well as a vertical line, then initiate the dimensions of 12 mm. Afterwards, we cannot find out what is the vertical length for this particular portions. Let's find out this area. Draw one horizontal line as well as a vertical line. Then form a fillet. What is the tangential? That is the radius of this particular fillet in this area is 5 mm. If you look at the front view, it is clearly explained called 5 mm radius. So mention 5 mm radius in the tab and choose this particular line profile, both the vertical line as well as a horizontal line, and form a radius on these portions. Now use and delete this vertical line, select this endpoint as well as this endpoint, mate it using merge entities. Afterwards, again I am going to draw one vertical center line on this area. Afterwards, we are going to make a tangential constraints on these portions. So select this arc as well as a line to make a tangential constraints. Once we form a tangential constraints on these portions, now draw one simple line profile. Look at this portion, that is the diameter of this area is 20 mm diameter. Now draw one single center line, then mention the dimensions from the endpoint. Select this endpoint as well as an vertical center line to give the overall diameter value of 20 mm. Then what is the vertical dimensions for this area is 43 mm. So mention 43 mm on this vertical dimensions positions. Now use a 3-point arc, connect both endpoint. Then assign the dimensions on these portions. What is the radius of this area? 880 mm. So use the dimensions and mention it 880 mm. Look at it, it is also constrained under that. Now I am going to change the leader types into radius format because it is easy to view the center point on this particular portions itself. Let's draw on another center line at another positions. Once we draw a profile, next we need to fix this area, but here we don't have enough dimensions to fix this profile. What is the diameter of this area? It is the horizontal dimensions is 68 mm, but we don't know about the vertical dimensions on these portions. Instead of that, use a 3-point arc connecting both endpoint, then make a tangential constraints on these portions. Then assign the dimensions. First selecting this arc as well as the top profiles, make a tangential constraint. Now switch this point up to its particular distance. Once we transfer this point locations, then mention the dimensions of this arc is 32 mm. Now the particular arc profiles is tangentially fixed from the top end. Okay, let's draw another horizontal line profile on these zones. So select a center line and choose this particular locations, draw one single line profile. What is the dimensions of this profile? The vertical dimensions here we have in the left hand called 6 mm vertical dimensions. Mention that. Now we are going to use a 3-point arc profile. Start from this particular end up to its end, then make a tangential formations. Now selecting this arc as well as the previous arc profile to make a tangential constraints. Then we need to assign the radius of this particular arc profile. What is the radius of this portions? 508 mm is the radius. So mention 508 mm in these conditions. Automatically the profiles gets fixed. Now transfer this leader type into a jog because the center point automatically takes its own places. It is much distance from our normal view. That's why I reduce it by using of a jog type. Once we draw a horizontal center line, now fix it using a vertical constraints up to its endpoint. Then draw another horizontal center line profile. Okay, what is the dimensions of it? It is don't have the enough horizontal dimensions, but the vertical dimension is positioned from the locations, that is, and from the end of its 6 mm, assign the vertical dimensions 10 mm. We don't have enough dimensions to fix this horizontal value. Before that, just draw the rest of the line profiles also, from the bottom one to final one. First draw one horizontal center line at the bottom locations. Fix it. Once we draw a line profile, then what is the dimensions of this horizontal area? 10.6 mm. If you take a look on the front view, the dimensions are clearly explained. 10.6 mm. But we don't have a vertical dimensions also. Instead of that, I am going to draw one 3-point arc by connecting both the endpoint, both the origin point as well as the endpoint. Let's fix it by using of a tangential constraints in the origin area. That's why I draw one horizontal center line, choose this line as well as the arc profile to make a tangential constraints. Then switch this point slightly on this particular locations. Then we are going to draw another horizontal center line at the required distance. Afterwards, what is the positions of it? From the origin, it is positioned under 26 mm. So mention 26 mm by using of a vertical dimensions 26 mm. Once we mention the dimensions, now we are going to connect both the endpoints by using of a 3-point arc. What is the radius of it? It is almost 320 mm. So use a 3-point arc, start from a particular endpoint up to its endpoint, then draw a profile. Afterwards, make a tangential constraints on the bottom area. So selecting both the profiles to make a tangential constraints. Then we need to assign the radius. What is the radius of these locations? It is 320 mm. Once we mention the radius, then switch to this particular location, then change back to another type in the leader format. Now we are going to draw on another 3-point arc profile by connecting both the endpoint. Just to use a 3-point arc, start from its location up to its location to make a tangential constraints. Now selecting this arc as well as this arc profile to make a tangential constraint on this area. Then what is the radius of it? It is also a same 32 mm radius, same as like our top and arc profile. Once we mention that, then slightly switch this point up to its locations, because we don't have enough dimension in these locations also. Instead of that, we are going to draw on another arc profile connecting both endpoint in a tangential way, then assign the radius on this area. Now selecting both the arc to make a tangential constraints. Overall, the total product designs comes under the arc profile itself, from starting to final portions, in a tangential format itself. What is the radius of this area? It is 240 mm. So mention 240 mm. Now this profile is also almost fixed. Only thing we need to done from this location is called vertical dimensions. Otherwise the points is not fixed, either from the bottom end or from the top end. Look at it, here the bottom point is also not fixed. Only one single dimension is enough to fix this overall profile. But in the drawing it is not clearly mentioned. So I just assume and give the vertical dimension in this current location is 4.5 mm. If I give the dimension, it is exactly similar to our 2D drawings as well as the products designs. That's why I initiate the dimensions of 4.5. That in between gap area. Once we mention this vertical dimensions, now we are going to close this overall open end profiles, because it is separated from each other. Just to draw one 3-point arc profile at this particular end. Now by connecting a 2 endpoint, it is automatically takes its own positions. Now I delete this profiles, use a 3-point arc, start from its point up to its endpoint to make a tangential constraints from the bottom end profiles. Now the profiles are tangentially connected with the top end as well as the bottom end. Look at it, the overall profile is created, but it is not closed. Within the center line, we can able to make a solid formations. So use a revolved boss, select this vertical line and choose a yes. Afterwards, within the center line, we can able to form a solid portions. Look at this product designs. It is developed from the single revolved boss features by drawing a multiple number of sketches to form a single profiles on this area. This is how we need to create this overall solid formation. Thank you.